Thank you. Yeah, it's probably a controversial topic, I'm guessing. But I hope at the end we can take some good key takeaways. So, striking the balance between good and perfect. Ready versus done. I like this picture because it was taken in 2018 or 2019, I can't remember now. That was Ember Conch in Portland, where I met a lot of beautiful people, a lot of amazing people. Yes, I'm so glad that today I can see so many familiar faces, but also a lot of new faces. Let's give a round of applause to the Emberfest team for putting this together, please. It's really lovely because Ember is home to me. And now I don't have to get a flight to go all the way to the other side of the Atlantic to see Meya again. So that's like absolutely perfect. I get to see Ed for free. I get to see Chris again. So this is really cool. Anyways, I'm Kenigbolo Meya Stephen, but you can just call me Stephen. It's much easier. I'm a senior engineering manager at Forest. You've had a lot of my colleagues speak today, and I'm not the last. I'm going to be the least. I'm a girl dad, a proud one. You can find me playing tea time a lot. I have those pictures, so much of them, trust me. And I'm an astute gallivanter. I got this title from one of our directors of product who said, Stephen, whereabouts are you in the world today? It's like, oh, I'm actually home in Finland. She goes, oh, okay, I thought you were hopping flights somewhere. I'm like, no, I'm home.
That right.
And the most important thing, I'm very good at missing connecting flights. Now, this is usually not a problem when you're in Europe. You've got like rules, regulations, if it's the airline's fault. It's a different situation when you're on the other side of the Atlantic. You don't want to miss flights there, trust me. Okay, and that's pretty much me. I like to teach, but I realized after being a father, it was not so easy to spend a lot of time teaching. However, I'm quite proud today that one of my former students actually got on the stage today, so I feel like a proud father.
Yeah,
Okay, let's look at what we're going to be talking about today. We're going to be defining what ready and what done is. We're going to talk about philosophical perspectives. Now, it's going to be more perspective than philosophy, to be fair, but it was like a nice, catchy phrase, so I had to put it there anyways.
no.
And then we're going to talk about practical implications. I like to walk the work, not just talk the talk. And lastly, we'll focus on finding the ideal balance between ready and done. Now, this is a very controversial topic. Being an engineer at heart, when I was actually putting this together, I kept on asking myself, but I did that also. So it's going to be a difficult one to go through, but let's see. Okay, so before we begin, a very quick question. How often have you felt caught between shipping a product that's good enough versus waiting until it's perfect? I'm going to give you 5 seconds to think about that. Okay, how many people spent that 5 seconds counting down the 5 seconds versus thinking about that question?
Right.
Fair enough. Cool. Okay, so today we're going to explore the nuanced tension between what ready is and what done is, basically in software development, and find ways to strike the balance between what we define as ready and what we define as done, but ensuring that we're having successful delivery without actually compromising on quality. So what does ready mean? Yeah, I've put that fancy definition there. I'm not really sure if this is what it means in software development, but this is what it means to me. And typically, for me, it signifies 3 things. Functional and non-functional requirements are satisfied. The product can be released to users even when it's not feature complete. Now, that again is a controversial one, but we'll talk about that as we go on. And lastly, business needs, timelines, or market demands are what dictate your release. What does done mean?
Okay.
It definitely goes beyond ready. Now, it could imply a sense of finality and technical perfection where no known issues exist. as engineers, we start thinking, yeah, the optimizations, the code refactors, the edge cases that we need to cover. We need to do all of those things, but an important question arises. Who actually benefits from those optimizations, those code refactors? Is it you, the developer, or is it your end client? And that brings us to something very important, which I'm quite passionate about: engineering satisfaction versus client satisfaction. What do we consider as engineering satisfaction? Whether we like it or not, and if you're shaking your head like, no, we all fall in that category at some point in our career. We take pride in writing clean, efficient, and elegant code, refactoring for improved durability, optimizing algorithms to be faster for performance, handling those rare edge cases. I recall very well Tohib on stage mentioned, I'm going to look into the code base and make sure it's like beautiful before I sign the job contract. That's engineering satisfaction. That's what we get from it. What do our clients really care about? What do you care about when you use a product? You want it to meet your business needs. It performs reliably, it's stable, it delivers value. That's pretty much a lot of what we want. Now, when you think about refactoring for readability, optimizing performance, all of this, handling all those rare edge cases, what it does align with isn't necessarily client satisfaction, it's more technical excellence. And as engineers, we definitely strive for technical excellence. So, a classic example, and I will give practical examples with what has happened at Forest. You need to share the few milliseconds of a query. It is definitely you striving towards technical excellence, but what is the actual benefit for the end user? Will they actually notice if you shared 0.0002 milliseconds of a query? Yeah, I think we all would know the answer there. Okay, this is quite important because as much as we don't like to talk about it, the fact is business needs drive our technical excellence. Business needs should drive our strive for technical excellence. Because if we can't ship products to people, well, we are going to be out of jobs soon enough, for sure. Which is why it's quite important to understand the balancing act. And this is not something that necessarily rests on your technical lead or on your engineering manager. This is a responsibility that we all have as engineers. It's quite important to always challenge what you want to strive for in terms of technical excellence by seeing if it actually aligns with the business needs of your product and your company. As engineers, we need to ask ourselves this question. Will this optimization, refactor or edge case handling provide meaningful value to the client or the user? Keywords there being providing meaningful value. Now we can talk about quantifying all of that later on, but we always need to ask ourselves this question. Does it actually address a problem they are facing, or is this more about making the code cleaner for my own satisfaction? The business value of a feature is sometimes, and most times, measured in the usability, your speed to market, and the overall impact that you actually have on the product. Clients typically care more about having a product that solves their problem. That's the reason why they pay you. They want it to be effectively delivered, and as the most important, it has to be within budget. I put those beautiful pieces in bold, and I'll be doing that throughout the slides today to point out important things. That refactor you want to do, does it add meaningful value? I'll give a practical example. We actually have a refactor going on. Our principal engineer, Tomek, has been doing a lovely refactor. And we had a conversation, myself and him, discussing why we needed to do this. And at the end of the day, these were the points that we had to look to. This refactor we were about to do, I had to understand if it was meaningful. What value was it actually going to give to the client, to the end user? What problem does it address? How does it improve our end users and their satisfaction? Or is it that, my principal engineer wants to feel satisfied that this has been done? Now, it's important that you prioritize what matters the most. And this is why we should talk about the collaborative approach. Like I just said, it's not just a responsibility of your engineering manager, your tech leader, or decision makers. It's a responsibility that we all share. Now, my personal mantra, something I will live and possibly die by, is the fact that it is not just one person's responsibility to prioritize improvements based on user impact and values. This is something you do together, both EMs, PMs, your technical leaders, and stakeholders. I would live and die by this mantra. Collaboration is the only way you build absolutely mind-blowing software. Now, coming together, engineering excellence in the context of user needs. Now, like I said, when we do something, when we want to do something, when we aim to do something, we always need to ask ourselves, is this something that gives me satisfaction as an engineer? Is this engineering satisfaction? Or is this something that improves the lives of our clients, improves the usability of our products? Is this something that the user needs? Yes, earlier this morning, Melanie said it's a journey to accessibility, and I really like that, so I try to incorporate it into my talk as well. The pursuit of perfection that we follow as engineers, while technical excellence is quite important, it has to be tangible, it has to be measurable, and it has to have visible impact for the clients that you have. Ultimately, the pursuit of perfection should always be grounded in this question: who benefits from this work? Is it me? Or is it my clients? Is it the people who pay to use the software I provide? Potential pitfalls of pursuing done. Now, as we said, done is the final state where we feel, oh, we've done all the optimizations, all the code refactors. This is perfect, excellent. There can be no bumper roads. I use this picture because they say a picture says 1,000 words. As you can see, there's two happy people there smiling, but it seems like there are two people who are looking away, probably not so happy. Over-engineering. This is one of the pitfalls of chasing the dawn state. You over-engineer solutions to strive for perfection. It's crucial as engineers, as developers, that we recognize and realize the point where that extra bit of work becomes diminishing return. It's important to understand that diminishing return doesn't always only apply to economics. It also does apply to the work we do as engineers. You need to be sure and be able to recognize when additional efforts start yielding minimal or negligible benefits. This is actually what separates good engineers from great engineers. Delaying releases. We want to make sure the project is absolutely flawless before we let it go out. It can work. I've seen it work. But most often than not, you'll encounter problems when you follow that kind of approach. And this is one of the pitfalls of calling the dawn state. Every line of code, every feature refinement that you have comes at a cost. It will come at a cost in terms of time, energy, and resources. Now, I hate to use the word resources because it's better not to refer to human beings as resources, but it kind of seems standard these days, so I guess I have to use it. And the last one, wasted resources. Didn't have a choice, so had to use the word again. Wasting resources and diminishing returns. You need to understand if what you're doing provides further value. Again, I will keep on reiterating. Is this for me or is this for the client? At some point, it is no longer proportional to the effort and value. So the effort you're putting has to be proportional to the value that you provide for your client, the value that it adds to the product. At the point where it's no longer proportional, you're basically getting to diminishing returns, and it's absolutely important if you want to take that leap from a good engineer to a great engineer to understand this and be able to recognize this. You probably had me ask David when he mentioned monorepo, moving to monorepo. I asked the question, what's the cost value benefits of it? Now, this is something as engineers as well. I'm saying this because it is not left to just your engineering managers or your tech leads. This is a culture as engineers we need to imbibe. Every engineering decision must balance cost against the value delivered. So for example, I wrote down an example here I'm going to give you. Polishing a feature until it works seamlessly across edge cases, it might improve the user experience slightly. But what if that improvement actually delays the release by weeks? Would you be able to quantify that? What is the cost? We want to polish this, but it means that in the next 6 weeks, we aren't able to actually release. Now, we work in a very fast-paced environment. You snooze, your competitor is one step ahead of you. It is critical for us as engineers to develop an intuitive sense of understanding when good enough is truly good enough. One way to approach this is constantly asking this question. Again, I would say, does this effort directly enhance user satisfaction or my satisfaction? If the answer to that question is no, which is it doesn't enhance user satisfaction, or the benefits are marginal compared to the effort, then you probably shouldn't be doing that. It doesn't mean it shouldn't be done, it just means it's probably low priority. This came from my CTO when we were making the talk. He said, perfect is the enemy of good enough. And I really, really like this phrase. Reason being, I agree with this strongly. And this doesn't just apply to us as software engineers or the work that we do. This also applies to every single thing that we do in life. The chase of perfection makes us forget to take a break, take stock of where we are, and appreciate the point that we're at. It is definitely the enemy of good enough. Now, for clarity, I am not saying chasing perfection is bad. I'm saying chasing it blindly can make you forget how far you've come. Again, we talk about resource. As much as I hate to say it, engineering is definitely about resource management, just as it is about writing code. Because at its core, the people who write that code are actually people. The code doesn't actually write itself. And making sure you can manage those resources effectively are key to enabling you build very good software. The best engineers I know are the people who can understand and prioritize their time across initiatives. What is the most important for the business, for the client, and for us as developers? So let's consider a project where 95% of the value is delivered by 80% of the work. The remaining 20% might be, probably do some optimizations here and there. Would you rather wait until all those optimizations are done, as opposed to putting that software out there in whatever version, beta, alpha, and then continuously gathering feedback and making those improvements as you go? It's not a one-size-fits-all. In order to actually effectively make that decision, you need to understand the art of trade-offs. Addressing diminishing returns is all about understanding how to handle and take care of trade-offs. Okay, let's talk about philosophical perspectives. Enough of the brouhaha. Well, we go more methodological. So let's look at waterfall versus agile, right? How does it embrace and emphasize where you're done? Waterfall, as we all know, is it's a straight path to done, right? We get to the next, we move to the next, and we move to the next. It's the waterfall model, and we have larger releases. With agile, it's more iterative, right? Agile embraces more of the ready state. We want to go in bits, we want to iterate, we want to improve, we want to go on and on. Now, when we look at DevOps, in Agile, we talk about continuous improvement. Right? The beauty of DevOps and then the DevOps mindset is that you constantly think about automation as well. And we will come to that because we have to talk about quality and not sacrificing quality. But these are part of the themes you could actually use to make sure that you have checks in place that do not necessarily sacrifice quality when trying to make those decisions. And my favorite one, pragmatism with idealism. Whether we like it or not, we get satisfaction from making sure that our code is nice and beautiful and readable and maintainable. That is the truth. We do have some engineers who value shipping more often. I have worked with both. I have seen the benefits of both sides. I think it's important to strike a healthy benefit, like a healthy balance between pragmatism and idealism. And what do I mean? I mean practicality, which is shipping software, and technical integrity, which is quality. So the goal here is not to say we want to go off and just ship things to our clients. No, the goal here is to say we want to balance shipping with making sure that we're not dropping the quality of what we ship. Okay, enough talk. Let's look at real things. Real things, yes. Okay, the ready approach. A team releases an MVP to get early feedback. Let's discuss this. I will give you a practical use case in Forest. We've been working, my teams have been working on a new version, so a clean, modified version of Forest. As you heard David say, we have a desktop app, and we decided to kill it, so we don't no longer want to be on Java Swing. And for that project, we actually took the ready approach. What we did was to build it to a point where we knew it had satisfied a decent amount of customer requirements, and we got that product into beta with existing clients, and iteratively, we have actually been gathering feedback, improving. It's not 100% complete, not yet, but it's been in the hands of clients for almost over 8 months. Now, what have we learned from this? Oh, there were certain things we had no idea of that were there. Lots of edge cases that we didn't even think of that we had to address. But most importantly, we've learned that clients would not always use the software the way you think they would use it. Oh, they're very creative. Very, very creative folks. And we work in the creative industry, by the way, so you can imagine. Okay, now let's look at the dawn approach. A team delays release to refine and perfect the product. Let's discuss this. One of my teams works on the reporting suite, and we had a client. In October last year, more like September actually, we started discussing, shipping this particular feature of reporting for the client. Again, these were decisions I had to make. So decisions I can, of course, sometimes external factors, but I will stand over because, again, I said I will give practical examples. Now, we had the option of doing this in 3 months in a way where we could get a significant amount of it done, but also roll it out to the client and gather feedback and iterate. We went with the dawn approach. It took us 10 months. Was the client happy at the end? Oh, it was lovely. He was absolutely happy when he got it. The problem was, he could have left. Because down the line, the client was so pissed that we didn't have it in time. The reasons why we still have him happy today have nothing to do with the 10 months we worked on it. It was more business relationships. Now, imagine that those business relationships weren't strong. And we had, because we obviously did, went through the dawn approach, spent 10 months building out for this customer, and the customer churned along the way. It would have meant that it's not just the revenue for this year, but the revenue for the next 5 years we have lost from that customer. Now, it did work out fine for us this time, but these are the possible drawbacks that you could have when you take the dawn approach. The better approach, obviously, would have been to build with the client. Build an iteration of it, ship it out to the client, gather feedback, improve, and go from there. At that point, you're definitely satisfying your customers' needs, but not necessarily going all the way to make sure that everything is perfect. Because I don't think there's perfect software anywhere yet. If there's one, please show me. I'm yet to see. Okay, so what are the impacts of each approach? Velocity. The ready mindset, it actually it improves velocity. You can go much faster, you can iterate, you can ship. The done one can slow down development. So like I said, we could have done it in 3 months. It took us 10 months to actually ship it out. We actually only shipped it out in August, actually, last month. Code maintainability. Releasing ready products I think I would even change that to will increase technical depth. It definitely will. It's not a might issue. It will increase technical depth. It will definitely require feature refactoring. Now, I know that we will start thinking like, oh, but there's never any time for refactoring. Well, if you do not have time for refactoring in your company, you have a fundamental problem for your engineering leadership. This should be something that is constantly forefront. You're not going to write bug-free software, I'm sorry. That's not going to happen. But making sure that technical depth is paid is not just a decision that is left for you as engineers, but a decision that you have to follow as a company, as a product team. Team morale. Yes, it has to be perfect. We need to get it done. I can tell you for sure, it would lead some people to frustration. I know this because we saw it firsthand. The ready approach, however, I would say may increase motivation because you have faster wins people can see. Now, this is where it's important as engineering leaders, as tech leaders, the case may be. You need to constantly make sure when you take the iterative approach, you can actually let your team see those wins. Could be screenshots of clients being happy, stats, whatever it is, but you need to make people see that you're making progress. And lastly, customer satisfaction. Striking that right balance ensures timely delivery without sacrificing user experience. Again, it's a balancing act, making sure that you're not sacrificing quality. So done. All right, let's look at strategies for finding the right balance. Number 1, set realistic goals. As much as I hate to say it, a lot of projects have goals that are not realistic. You need to define your MVP from the very start. And I think it's quite important to use prioritization frameworks, and in this case, something like Moscow. And no, I don't mean the Russian capital, by the way. I'm actually referring to must have, should have, could have, won't have. Using those models to make sure you set realistic goals and understand what you're actually building. Iterative development, this is my favorite. Perfection is a journey. It's not a destination. Like I said, we can all strive to build perfect software, but if you have perfect software anywhere, please show me. If there's a bug-free software somewhere in this world, I would actually like to see it. This is where continuous integration and development comes in, making sure that you can build in steps and build with your clients, not just for them. Quality without over-engineering. Now, I know when we mentioned we need to strike a balance, there are certain things you can actually do. Test-driven development is a tested and tried way of ensuring software quality. It's one of the things I'm proud of about the code base that we have. Tests are a fundamental part of how we write code. So yes, indeed, you can actually balance quality without over-engineering. You can automate repetitive tasks, for example. Things as simple as linting can help find a lot of things. And last but not the least, I will mention avoiding unnecessary optimizations. As engineers, we definitely always fall inside that trap. Oh, I'm going to shave a few milliseconds of this. Yes, it's absolutely fantastic. Is the client actually going to know that you save 0.002 milliseconds? In a large bunch, yes, it does make sense because all of those could, add into, shaving 2 milliseconds, 5 milliseconds, but then you come back to the question of cost-benefit analysis. If the software is already reliable, yes, we're trying to make it more reliable, but could the amount of time have been spent working on something else? avoiding the perfection trap. Just by a show of hands, how many people have a proper definition of done on their Jira boards or whichever boards you use? Okay, that's a few hands. Interesting. Now, this is something I strongly hold. If I talk to a few of you from the same company, and because I did try it earlier on during the break, and you have different definitions of done, it actually shows you have a problem. This is actually important because that's how you avoid the perfection trap. You understand what is done. You have a clear understanding. Now listen, we have standard board. We can use like the to-dos in progress and done. Like every company would have a variation of it, yes. But when you say something is done, what exactly is it? Do you mean this is in the hands of the client, or you mean there's absolutely no bugs, this has been tested thoroughly? Is that your definition of done? It's actually quite important because not using feedback loops and not having a pure understanding of what you define as done shows that there is a problem in how you ship software. And this is my favorite one. This was actually pointed out to me by my colleague Ife. Rigorous scope refinement. This should be a shared responsibility. It is for the entire team, not just your PM or your tech leads. This is the most effective way to make sure you're balancing ready and done. I think it's very common for engineers to rely on our PMs and our tech leads to actually set this, and we just simply follow the plan, like sheep following a shepherd, which is fair, but I think this usually results in missed opportunities to actually cross-check and criticize and challenge, unnecessary or ambiguous requirements. I believe we all work with designers here. If they give you some really fancy UI, oh boy. But that usually means you can sometimes look at it and say, oh wow, okay. But why are we having to do this? Is there not a simpler way to do this? Could we not do this with less time? Isn't this more complicated than just doing it the simple way? What are the benefits of actually doing this? This should actually be a collaborative process, and that's why scope refinement is absolutely important. Now, it is absolutely important to challenge the scope. One of the things I strongly encourage those who work with me as well is challenge things. You have to. Because at the end of the day, yes, the buck stops with me, but the team would also look bad if we screw things up. So please challenge things. Challenging the scope before starting development is absolutely important. But what exactly does this mean? Nope, not this. It's definitely not this. It's more like this. Having a conversation in a civil way. Now, it's important because a lot of the times we misunderstand challenging things from being oppositional. They're two different things. Before diving into development, it's crucial to engage in rigorous question. What does it not mean? It doesn't mean being oppositional. What it actually means is critical thinking about whether every feature optimization, edge cases is actually necessary and provides value to your end user. Scope creep and feature bloat often arise due to lack of refinement, not spending that time during the planning phase. If engineers don't actively challenge these areas, you end up spending significant time on tasks that are actually just not important, do not add value to the client. Let's look at a proactive, collaborative approach. At the end of the day, as engineers, we are the ones who would actually implement solutions, not your engineering managers, not the stakeholders. You as engineers are the ones who actually provide solutions to the problems. This is why you're better positioned to challenge these things from the inception. That's why scope refinement is absolutely important. Engineers need to challenge. I would say it again. If you see something that doesn't make sense, if you see something that has a simpler way to do it, that doesn't affect the quality, challenge it. It doesn't matter if it comes from your engineering manager, from your tech lead, from your designer, challenge it. That's how you build better products. And what are the actionable steps we can take? like I said, you need to have a dedicated session before you start working on anything for scope refinement. It's absolutely important. And during the session, I think we need, as leaders, we need to encourage engineers to ask certain questions. Absolutely important. And these are my favorite ones. Again, there might be variations, but I think they all always boil down to this. Is this feature essential to the MVP? Are there simple alternatives that will still satisfy user needs? Is the expected value of this not talk, what the development cost? Now, I use talk specifically because in this case, your PMs are mostly talking. They're not actually writing code. But is it actually what the development cost that you actually put in? So, a quick recap to conclude. The key points I want everyone to take away today is, 1, the main difference between ready and done comes down to balancing delivery speed with quality. Ready generally refers to functional, usable, and meets your initial requirements. Done, well, it's a good thing that we don't have a unified definition of done across companies here, so that's really nice. But the idea of chasing those endless refinement might generally mean you potentially delay your releases. Lastly, there's no one-size-fits-all. Adopting an agile mindset, making sure that you can iterate, making sure that you can balance quality, and navigating that balance is absolutely important in making the best decisions. And my final thoughts, I really want to encourage us to move beyond perfectionism, but without necessarily compromising quality. Perfect may never come, but great products can, and we all can build great products. Thank you. Tak, sumikat. Kiitos.